Hi folks, so the questions we have in front of us here today, guys, are the 2018 Section A Ordinary Level DCG questions. As always, 4 questions, you have to do 3 of them, okay? So what we're going to do is we're going to work through them one by one, A1, A2, A3, A4, okay? Starting off with A1 here, which is based off of the topic on conics, so a little ellipse question here. So I'm just going to zoom in on that one there now. So the question A1 says, the 3D graphic below shows the proposed design for the new Children's Hospital in Dublin. It consists of an ellipse and 2 inner circular arcs, okay? So we can see the ellipse on the outside of it here. Then we've kind of got 2 little arcs there as well. So they're trying to represent that here. So we can see a bit of a portion of the ellipse here, and we have to get 2 arcs then on the inside. The drawing on the right shows the major and minor circles. So we've obviously got the large circle, which is called the major circle. Just going to identify them there. So that there is the major, and then inside here, I'll do it down here, is the minor. Okay, so major and minor circle. And it also says for the ellipse, portions of the ellipse and of the inner arcs are also shown. So we can see we've got a bit of the ellipse here, and we've got the first inner arc, and we've got the other one here, but we just obviously have to find the center for it. So it says part A, locate the remaining points in the ellipse and draw the curve. Part B, locate the focal points of the ellipse. And then part C, locate the center point for the lower arc. So that's what I was thinking, we'd have to complete that. So what we're going to do here is, for anyone who did junior cert drawing, you'd remember this from your concentric circles method, and from leaving cert drawing as well, you would have learnt this. So what we're going to do is, the easiest way is we're going to split our circles, our major circle, which is the outside one, and the minor circle, into 30-60 degrees. So right through the middle, 30 degrees this way, and hopefully this one is at 30 degrees. Yeah, it seems to be. I'm going to continue that on. I'm also going to go 60 degrees up through the middle, and likewise 60 degrees in the opposite direction. Okay, start off by identifying some points on your arc already. So the extents of the major axis will give me 2 points here and obviously over here, and the extents of my minor axis, which is going from here to here, will give me another 2 points. Okay, so there's kind of 4 points. You can see the direction the ellipse is going to take, like that. Okay, the shape it's going to take, I should say. So what we do is, and this is important to note, so usually what I do in class is, for the major, I'd write MAJ, and I'd identify the direction of the major axis, which is going from left to right. The minor, which is up here, MIN, and I know my minor is going up and down vertical. Major, horizontal, minor, vertical. So where are lines? So if you take this one for example, which they've already identified for us, you can see here where this 30 degree line is cutting through the minor circle and the major circle. Where it cuts through the minor circle, you go parallel to the major axis. Okay, so you can see the major axis going left and right. So where it cuts through the minor circle, we went left, and where it cuts through the major circle, we go parallel to the minor axis, which is going up and down. So where it hit the major, we go down. So likewise, we do the exact same for the other points. So take this 60 degree line for example. So where it cuts the minor circle, I'm going to go parallel to my major axis. So in this case I'm going to go left, and where it cuts the major circle, I'm going to go parallel to my minor axis. That helps me identify another point. Now I can go a little bit quicker than that. I can, for all my minor circles, I'll go parallel to the major. In this side I'm going to go right. Likewise with this point in here, I'm going to go right as well, and do the same underneath. Left for this one, right for this one, left, and then finally right. Okay, now to identify the other points, every other one where it hits the major circle, you can see here I'm going to go up at this side, up. Now on the opposite side, this one I'm going to go down, this one I'm going to go up, this one down, this one up. That will help me identify some points on my ellipse. You can see here I've identified some of my points. So there we have it. I'm going to sketch that in now as neatly as I possibly can. Okay, so there we have the ellipse. Okay, that is the part A completed. We've drawn the ellipse, so I'll just take that off. Now I have to locate the focal points. Now, anytime you're finding the focal points, what you do is you take half the major axis. Okay, so my major axis is going from this point all the way out here to this point. So I get half of that. So essentially the radius of the major circle, which is that distance there. And I can go to the top of the minor or the bottom of the minor. So in this case, I'll just go to the bottom. I'm going to swing an arc to cut the major axis here and here. Likewise, if I did it from this position, it should give me the exact same point, and as you can see it does. And there we have it. You don't have to do it, you just have to do it from one side, and usually what you would call them is F1 and F2. So that is your focal point 1 and your focal point 2. So that's the second part. And the last part, it says, part C, locate the center point for the lower arc and complete the drawing. Okay, there's a couple of ways you could go about this. They've obviously given us the first arc, and we actually have the point here in the second arc. So one way we could identify it is, obviously the center point is going to be up here somewhere to draw the arc, so the center point has to be up here. I'd imagine it's going to be somewhere up along this line. Okay, so I might extend that just a little bit further. I'm not 100% sure where the arc is, or the center point is, but just to have a little guide, so you can see I'll put that in very lightly there. And one way I could do it is I could maybe make a chord from this point here to this point here, bisect it, and find it where it is down here for this arc, take the distance and mark it up. But I could also, probably the easier way and quicker way, would be to identify the way that point is there, that point right there, would have to be equidistant down on the other side. So I could take that distance with my compass. Okay, I'll do a little semicircle like that, and what that does is it helps me identify where the point is at the opposite side. So I have 2 points now on a curve. I have this one and this one. Actually I have 3 points, but we know the center is somewhere up here. So what I can actually do now is I could connect them like a chord of a circle, and we know if we bisect any chord on a circular arc, okay, we can actually identify the center. So I've connected that to 2 points to make a chord, and what I'm going to do with this line here is I'm going to bisect it. So take a distance greater than halfway, swing an arc with the same distance on your compass, go to the other point of the line and swing another arc, and where that chord, or sorry, where the 2 points cross each other, right here and here, I'm going to extend them on. And what you can actually see then is, I told you the center was somewhere up here, I can see my center is right there. So now that I've identified the center, I should be able to complete my arc, which is the part C, locate center point for the lower arc. So I found the center point, it's roughly there. I want to get it as accurate as possible. So before I draw it, I would always obviously mark it onto it, make sure it's going through, put it a little bit high there, so about there, make sure it goes through the other side. Yeah, I'm happy with that. You can see it's going through there, and there we have it. Okay, so there you have it. I found the center point by creating a chord, okay, right here. First of all, identifying this point by just marking the equidistance down, a bit of axial symmetry there, and then making a chord and bisecting that chord. Okay, so a little bit in that first question on conics there, that was an ellipse, okay, using the concentric circles method, locating our focal points, and then obviously creating a chord to find the center point of a circle, okay, or of an arc. So what we're going to do now, guys, is moving on to A2 at the bottom of the page, which is a question on solids in contact. Okay. So this question A2, it says 3 stone containers for growing flowers are shown in the 3D graphic below. So we can see them here. We've got a cylinder, we have a truncated cone, which is upside down, okay, an inverted truncated cone, which has been kind of, what I mean by truncated is that it's cut, so we don't see the top point. And we also have a hemisphere as well, okay. The containers are in the form of geometric objects which are in contact as shown. So the cylinder is touching the truncated cone, and also so is the hemisphere touching the truncated cone. The drawing on the right shows the elevation and partially completed plan of the object. So we've got the full elevation done, and we've obviously only got the truncated cone drawn here. Okay, and obviously then you can see it's open obviously to have flowers because that's the base of it here, the inner circle. The larger circle would be the top of it. Okay. The arrangement consists of a cylinder, a truncated cone, and a hemisphere. Part A, draw the plan of cylinder B. So draw B in our plan. Then part B, draw the plan of hemisphere C. So hemisphere C is down here. So starting off with part A, draw the plan of cylinder B. So the good thing is we can identify straight away where the center point is. So the center of hemisphere or cylinder B is right here. So if I was to project that down, my center has to be somewhere out there. And the good thing to note is that cylinder B is touching right here on the extreme generator of our truncated cone. Okay, because that's on our extreme generator, in our plan our extreme generator is seen as the axis line. Okay, so where that touches, technically, I can bring this down right there, and that's actually showing me right there the point of contact, which would usually be POC, like that. Okay, point of contact. But because that's touching there, my center point also has to be out along here. So right there is my center. Now I can draw in my cylinder as I look down the top of it. So just grab my compass, take the distance from the center to my point of contact. And what I'm going to do is I'm going to draw that in my plan view, hopefully without slipping. Okay, and what you can see is obviously I haven't finished it inside here, but because the truncated cone is slightly higher than the cylinder, technically the bit underneath here, that wouldn't be seen, so it goes in as hidden detail, like that. Okay, so a little dash line there. Now that's part A done. Now we have to draw the plan of hemisphere C. So once again, very good, very helpful. We can already identify where the center of hemisphere C is, because when we look down the top of it we would see another circle. So the center is somewhere down along there, and this time now it's slightly, if you look at the graphic over here, it's slightly to the front of the truncated cone. Okay, so it's not going to be just right here to the side of it, it's probably going to be somewhere down here. Okay, so what we actually have to do is we actually have to create a ghost hemisphere in this position here, okay, or identify just where the center of it is, and before we rotate it around. So it's like we're going to put it at the side in the position that it would be if it was right at the side touching the extreme generator, and then rotate it into its correct position somewhere along this line here. So the center of it isn't going to change, alright, so I'm just basically moving it. Now anytime we would have done this in class, what you do when you have a cone is you're going to bisect the angle between the extreme generator and the XY line. So that's the first step we're going to do there. We're going to bisect that angle, the angle created here between the extreme generator and the XY line. Bisect this, so pick a distance, and then there and here. And what I'm going to do now is in here, connect that back to there, and what you'll actually find is, because I told you the center here, it's going, or sorry, the radius and the top of it, which is right here, it's going to still stay at the same height, but all we've done is we moved it, and where it bisected to, where it is here, that's going to be the position of it when it touches, okay, on the extreme generator. So if I was just to draw that in and put it in red, just to help with the understanding, I'm going to take the same distance here, the same radius, I'm going to move it here, it's going to be from there, I'm going to draw it in, and this is generally what would be called a ghost hemisphere, okay, because it's not the correct one, it's just the ghost one to help and guide us. And what you can see is I've basically taken this original one in the correct position and just moved it over slightly. And what really I've done is I've rotated it about the truncated cone A. So now that we have the ghost one touching on the extreme generator, and remember I said the extreme generator of the cone, or the truncated cone, will be seen here as the axis line. Therefore my ghost one has to be somewhere, center of it has to be somewhere out along here. So I've got the center up here in my elevation. What can I do? Bring that down. And where it is here, what am I going to do with it? I'm going to rotate it around. Because now I've got the ghost one, I can rotate it about the truncated cone using the center of that to the position of the ghost one, which will be here. Not going to draw it in this time. And just rotate it like that. And where it rotates and hits here, I've now got the exact position of my center point for the hemisphere. So I'm going to draw that in now. Hemisphere will be seen as a circle. So once again, take the exact same radius as we previously had. That guy right there. Using this. Once again, it's slightly underneath it. So same as last time. I'm going to heavy in the outside part, because the truncated cone will be above it because it's higher. So there we have that. Now what I'm going to do is inside here, that will be his hidden detail there. Okay. Now the point of contact technically is right here. So if I wanted to show that as well, between the two of them, that's where it was when it was, sorry, brought down with the wrong colour. That's where it would be had it been with the ghost sphere. So with the same principle, I could rotate that around. Okay, and what it's actually going to show me is, when I connect the center of both, it's showing me that the point of contact is right there. POC. So there's a POC here for the cylinder and the truncated cone, and then I've got a POC here in my plan. And to find it in my elevation, I'll simply project it back up, and my point of contact is there. So there we have it. Okay. They didn't ask us for the points of contact or anything like that. They just asked us to draw it in its correct position in our plan view. So there's the cylinder in the plan view, and there is my hemisphere. So cylinder B and hemisphere C. Okay. Now what we're going to do is we're going to move on to A3 at the top right of the page. Alright. So this question, guys, A3, it says the image below shows the Mary McAleese Boyne Valley Bridge, a suspension bridge across the River Boyne in County Meath. The drawing on the right shows the plan and partially completed and a partially completed perspective view of the concrete tower part of the bridge. Okay, complete the perspective drawing of the bridge. Right. So what we have to do is, as you can see, we've kind of got a partially completed part of the perspective here, so we have to complete the rest of it. So there's probably a bit that comes down here, it comes down as well, obviously at a certain angle. We have to figure out those parts. So just a little bit and using our vanishing point. So everything is kind of set up for us here. So this is a nice question actually to get, okay, if it happened on the day. So the first thing I'm going to do is, this face here is coming down straight. If you kind of look over here, it's hard to see, but it's obviously coming down straight. Okay, so I can actually extend this down further, and I know where it's going to jut out because there's obviously a little ridge there. So I'm going to come down parallel to this. That's kind of my guide. So just with a sliding set scissors, just to be 100% accurate. So that will come down to there. I can heavy that in as far as there. I know I can also heavy this bit in. Okay, so there's that first bit done, probably the easiest part. The next part I want to identify probably is where it's going to finish down here. So it's obviously finishing like that, it's probably at road level, so I'm trying to identify maybe a point right there on the road. Okay, so trying to find that. So if you think of this point, which was here, okay, so if we follow it, that's the plan view of it. So that would have given me this one and this one. Now that's going to connect down to here. So I can see the spectator's view of that is where I bring it to the picture plane, bring it to the spectator, sorry, but where it hits the picture plane, I'm going to bring that down. So that's where it's actually hitting. So I'll project that down there. And that is identifying how far this bit is going to jut out, and with that then I can actually connect that up there. Okay, at this point it probably looks like you're done, but you're not, because obviously we can see inside here we have a little bit inside here as well. So I thought I also identified that. There's a couple of ways you could probably identify it. I could probably bring this point up here down to my spectator where his pitch plane dropped down, but it'd be quite easy. I could just use this because that's the same width, and I could vanish it because this point here, the face is going in that direction, so that will vanish to VP1. Okay, and that identifies this point here for me, which is really helpful. Now the problem is that point there connects up. So if you look at the front face here, you can see it connects up the front part of it, right? And the back part is just going to be the mirror image of it, only in a perspective view. So this bit here connects up right up to the middle. Okay, and likewise with this one. So it's going to be the same at the back parts. This guy is going to connect up right up to the middle there somewhere. So I have to identify the middle up here, and you can see here. So for this one, just to show you, if I follow that up, follow it back, you can see the middle is here. So this guy is the guy I'm going to need at the back. Okay, even though I won't see him, he's inside here somewhere, but it'll give me a guide to get this kind of edge in there. So to be able to do that, I'm going to project that point down there, up here, sorry, to my spectator, where it hits the picture plane. I'm going to drop it down. Okay, and that point right there, okay, in there is going to give me a guide. Okay, and that's actually going to show me the ridge of the line, or the edge of the line, and I'm just going to heavy in that portion of it there. Okay, now you don't have to show hidden detail, but technically there'll be an edge in here and also an edge in there like that surface as well. Okay, so not too much in that one. If that question came up in the day, I'd be very, very happy. Okay, in the exam you should people would find that quite comfortable. Okay, that's a nice little perspective question there, where a lot of it was set up for you, and it's just you can get good marks on that for just doing a couple of lines. Okay, so that's A3 done, guys, on the perspective. Now what we're going to do is move down to A4 at the bottom of the page. Last question. Alright, so A4, it says the image below shows a concertina. Okay, so you can see it down here, a little kind of musical instrument. The instrument is hexagonal in cross section. So basically what they're saying is, if you were to slice through it, the shape it makes is a hexagon. Okay, the plan and elevation and the partially completed end view of the instrument are also shown. So we've got the fully completed plan view here, we've got the elevation here. The elevation is obviously when we're looking in this direction, so we see all this face, we're seeing these faces, and obviously there's a bit of hidden detail of these back edges down here. Okay, and obviously a bit of hidden detail there, which is that ridge running along the back there. It says part A, complete the end view, so we have to finish off this guy and then draw the true shape of the end of the instrument. Okay, so the true shape of the end of the instrument. Right. And technically there's two ends. They haven't specified which one, but I assume with the space we've left out here, we'll have to do it off that one. Right, so what we're going to do is part A, complete the end view. So the end view, guys, is got over here, and what that means is we're essentially looking at it from this direction if it's on the right hand side. So when we're looking, if there was like a person here, okay, and that's his head, excuse me there, it's a terrible sketch, but he's looking in this direction at it. Okay, he would see all of this face here, and technically, if you imagine he was obviously further back, okay, he would also see this face here and this face here. The face he doesn't see is these kind of ones, okay, and he wouldn't see the back surface there, so they'll all be in hidden detail, but he would see this face, which is technically this face here. So we're going to project those across. So you can see here they've already got some of these rotated across. So likewise I'm going to do the same with this one. I'm going to project that across here. I'm also going to project this guy across. I'm just going to work on that bit for the start, take our time with it, and from the corner of my elevation right here at this point I'm going to rotate up. I usually use a 45 degree line, but they've gone with rotation here. of rotating our width, so I'm going to stick with that. I'm going to rotate that up like that, and likewise with this one. Okay, so that there is going to show us the width of it. So I'm going to project this guy up. Project this guy, he'll come up about halfway. And what I'm going to do is, if I was to just use labels for a second, and let's say I was to call, I'm going to use letters. I'll call this A, B, C, D, E, and F. Okay, so A, B, C, D, E, and F. So A is at the top, it will be up here. B will be here. Then I'd have C on the outside. D is underneath. B, E, and F. Sometimes if you use a bit of lettering, it can help you. So to locate A is going to be followed across, rotate up, so it's up along this line here, and A is at the top, so there's our A. B is already up here. C, same height, so there's our C. I want to find my D, so there it is, there's D. Now I want to find E, so E comes across, it's on the same level, so there's our E. And finally F. So F is going to be somewhere up here, so what do I have to do? To bring F across, nice and easy. Bring that across, make sure I'm doing it correctly. So I'm going to need it over there, and there's F. Okay, so there's my F. Now, having done that, I can actually draw that all in fully. So F connects to E and to A. So there's that face there as we look at it. Now what we're also going to see is F obviously connects all the way to the back over here. So there's that bit, maybe in that as well. Okay, and now obviously we have another hexagon at the back, but as we're looking in this direction, we can't see it, but we still have to put it in. Okay, so likewise, same method now. I'm going to project that across there, and likewise they did with these guys. I am also going to rotate this guy and this guy up as well. Okay, just to be able to identify them. So he's all the way up here at the top. There's that one, and then finally this guy here. So you could do the same like I did with letters. I could continue on F, so I could go G, H, and so on. Okay, so you get the idea. But I'll save myself a little bit of time here now, because I know this point here is in relation to this one and this one here. Okay, top and bottom. So at that one there I have to project up a little bit as well, right up to there, so that'll give me a point up here. And at this guy then, he's on the outside, so I follow him around, he's here, so he's going to be right there. So at that point then, it's a case of heavying in my information. I say heavy in, I want to put it in as hidden detail, and just make sure I'm getting the right line. Yeah. And that technically would be the back face of it here. And likewise, the way we had an edge here, there's technically an edge running from C all the way down to here, and that edge also we do not see, so more hidden detail. Okay, so there is part A done, completed the end view. Now what it's saying is, last part is draw the true shape of the end of the instrument. Now there's a couple of ways you could do this. You could take an auxiliary by looking perpendicular to the face, A, B, C, D, E, F. Okay, like that. I'm going to take it off this one. I could technically do it off this one. Never specified, but I'm going to use this one. Okay, because I have the space over here. So I could take an auxiliary by projecting, an X1, Y1, okay, parallel to the face, and then projecting perpendicular to it. But probably the easiest way and the most quick way would be to do a rebatment. Okay, rebatments are handy as long as you understand how to do them. So from F, actually, I'm going to do it off of F. I'm going to rotate, and I'm going to treat the face like a door. Okay, so this is the edge view of the face, because we see it as a line. I'm going to make F like a door. Okay, I know I'm going out into the drawing here, or into the pictorial view, but F is like the door. So what I'm going to do is, F is the hinge, I'm going to rotate A, B, C, D, and E about F. So for C would rotate like a door until it's in this position right here. Likewise with B and D. And hopefully this will reach just about with A and E. Okay, so there we have A and E as well. Okay, so now what I've done is I've essentially just got the door, rotated it around until it's in this position. Now A and E are here, so I'll do A, comma E. I've also got B, comma D, and then finally C. And I know it's hard to see there, apologies for that. But F is the hinge, as I said, so normal orthographic now. We've just rotated the door, and how that rotation would appear up here is just straight lines, horizontal, parallel to your XY line. So this one is for C, B and D, and then finally A and E. So let's locate them, check these guys across. F is going to stay in that's the one that's going to be constant and stays in the same position. So let's follow them. A is up here and A, so it matches there, so there's my new A. Then B. Okay, I want to find C, which is out here, same level. So there's my C, you can see where this is going. There's my D, there is E. Okay, and you can see it, A, B, C, D, and it's simply a case now drawing it in. So there we have it. That there is essentially, it's like I rotated it around, okay, and that there is my true shape, okay, which is what it asks for. Draw the true shape of the end of the instrument, okay. And we could have done that both ways. I could have rotated it around here like that, rotated it down. Makes absolutely no difference how you went about it. I just think that was probably the easiest way, okay. And that was done by a rebatment. Now the other way, as I said, you could have done is an auxiliary view. Okay, that is the question A4 completed, guys. That is all the questions completed from the that was the 2018 ordinary level section A. Okay, hope you found that helpful. That's them done.